Since I don't know of a free multi-platform graphing calculator or an online calculator that does 3D graphing the way that we need it here, I'm showing you this on my computer. Grapher is the program that we're using here. It's a free program, but it is Mac only. I will put the file online in case you want to play with it, either if you have a Mac or get yourself to one of the Macintosh computer labs on campus. So one nice thing with this calculator, I can kind of swivel it around with my mouse like this to get different perspectives on things. Notice that I have an x-axis, a y-axis, and a z-axis. So I'm not going to require you to do any three-dimensional graphing, but we do want to develop some intuition for what's going on when we're solving these systems. So let's take a look at the graph of an equation. So we'll start with this one. As you read in the reading, this will be the graph of this equation will be a plane. It's in that form. I can show that by clicking this checkbox. And so here is my first plane. And of course, in reality, this extends infinitely far in every direction, although that does make it a little hard to look at the picture, so we're just looking at a convenient piece of this plane. We have another one in this system to look at. And so notice that these planes are parallel. Just like you can have parallel lines when you're graphing in the plane, in three-dimensional space you can have parallel planes. These planes never touch, so this system has no solution. And, well, that's what parallel planes look like. Okay, so let's look at another system. Here we have another system that consists of two planes. I'm going to show this first one. So here's my first plane. It's a green one. And my second plane in this system. So these two planes do intersect. When you have two planes that intersect, they intersect in a straight line. So let's look at that line. So there is the line that is the intersection of those two planes. It's sort of hard to see right when it goes through them, but you can tell that that is. Now when you're giving the it can be a little tricky to give the equation, it's not strictly an equation, of a line in three-dimensional space. You need to do it parametrically. This is why when we have infinitely many solutions, we have to have an arbitrary variable and specify the coordinates in terms of that arbitrary variable. We'll see some examples where we do that algebraically in a different video, not in this one. Today we're just looking at pictures. Alright, so that is two intersecting planes. Notice that there are infinitely many solutions. So if you have two planes, either they intersect or they don't. If they intersect, they have infinitely many solutions. If they don't intersect, then they have no solution. So now let's look at what happens when you have three planes. So here's my first plane. Here's my second plane. Notice that my two planes intersect in a line. And my third plane intersects both of my other two planes. There is one single point where all three planes touch. So my first two intersected in a line right along here. My blue plane came in and touches that line, that is the intersection of both of the first two, right here, and this single solitary point is the solution to the system of three equations. I should say these three equations. These planes are the graphs of these three equations, and their mutual intersection point, this one single point, is the solution to this system. So let's look at some other ways that three planes can interact. So I might have, well, here's one plane. There's another one. Those two intersect. And then I have this green plane that intersects both of the other two, but there is no mutual intersection with all three planes. There is no point that is on all three planes. We have three lines of intersection between two at a time, but being on two at a time is not enough to be a solution of this entire system. So this system has no solution because there is not a point that is on every single plane at the same time. All right, now let's look at our final example. So here we have two planes that do intersect. I've got a pink and a blue. And then we've got yellow. And notice that, oops, let's look at this from the end. Notice that all three planes do intersect. They intersect along a line. So every point, let's see this intersection. Every point on this blue line is on all three planes. So there are an infinite number of solutions, and we can specify them in that parametric form like this. We don't write it like this as this. Well, this is a little misleading. That's just how the graphing calculator needs it. But every well, like I said, I'll show you how to specify that algebraically in a different video. Right now we're focusing on the way the planes can interact. So if you have three planes, they can intersect in a line like this example. They can intersect in a single point like this example. Or they might not all intersect at all. Now there are different ways that planes could fail to intersect. You might have them be three parallel planes or two parallel planes and one transversal. Either way, as long as there are no points that are on all three planes at the same time, there's no solution. If you do have this situation, you have infinitely many solutions. And if you have our first situation, you have one single solution, one single point that is the solution to the system. So hopefully that helps understand what we're doing in the big picture sense. Next, we will have several videos of actually solving systems algebraically using matrices so that we can actually find some solutions.